And welcome back as we go ahead and look at our first interface example, which is the comparable interface. So when we start looking at these interfaces, let's go ahead and do this by looking back at an example here. So previously, we had looked at a method for sorting a partially filled array of base type double into increasing order. It's very easy to transform this code into a method to sort into descending order instead of increasing the order. It's also very easy to modify your code to obtain methods for sorting things like integers instead of doubles, or to sort things like strings into alphabetical order. Now, at the root, all these sorting methods are essentially the same. The only differences are the types of values being sorted and the definition of ordering. So is it going smallest to greatest, greatest to smallest, etc. Therefore, if we kind of think about this, we should be able to give a single sorting method that covers all these cases because they're ultimately doing the same thing. We should find a way that we can generalize this. The comparable interface actually will let us do this. So let's dive into what the comparable interface does. So the comparable interface is in the java.lang package and so is automatically available to your program. The interface has only the following method heading that has to be implemented for a class to implement the interface, which is public int compared to object other. The comparable interface has some semantics, and it's the programmer's responsibility to follow those semantics when implementing the interface. So let's look at that compare to method. The semantics simply say that compare to returns, right? Well, it's either going to return the following. First, you'll have a negative number if the calling object comes before the parameter other. It will return 0 if the calling object equals the parameter other. And it will return a positive number if the calling object comes after the parameter. Almost any reasonable notions of comes before should be acceptable. All of the standard less than relationships on numbers and lexicographic orderings and strings are also suitable for ordering for compare to. And the relationship comes after is, if you think about it, just the reverse of comes before. If you need to consider any other ordering, the precise rule is that the ordering must be a total ordering, which means the following rules have to be satisfied. First, it has to be irreflexive. For no object, does O come before O. It has to have trichotomy. For any two objects, O1, O2, 1 and only one of the following holds true. O1 comes before O2, and O1 comes after O2, or O2 equals O2. And in case you're wondering, O just is a variable for the object, in case you're wondering here. And lastly, you have transitivity, which is if O1 comes before O2 and O2 comes before O3, then O1 comes before O3. So let's, of course, again, referring to those variables, you have multiple objects in play here. O1 being object 1, O2 object 2, etc., and so forth. When we really kind of deep dive into this method, the equals of the compare to method semantics should coincide with the equal methods of your classes if possible. But this is not absolutely required. If you define a class that implements the comparable interface but does not satisfy those conditions, then the code written for comparable objects will not work. It's the responsibility of you, the programmer, to ensure that those semantics are satisfied. Now, neither the compiler nor the runtime system enforces any semantics onto the comparable interface. So the best way to do this is use an example, right? How do we actually implement this? So we're going to look at in a minute the generalized selection sort, which is going to show a class with a method that can sort any partially filled array whose base type implements the comparable interface, including implementing the semantics we just discussed. So if we want to obtain that code, we start with a selection sort of an array of doubles and mechanically replace all occurrences of that double array with a comparable array. You're just swapping it out from one type to the next. And we replace all Boolean expressions of the form Boolean 1 or expression 1 is less than Boolean 2 or expression 2 with expression 1 dot compare to expression 2 is less than 0. And you notice it's a less than 0 here, which if you remember, we have seen this before when we dealt with things like alphabetical or lexicographical order. And therefore, if you actually think about it, there's only actually 4 changes that we need to make from our selection sort class to use in our generalized selection sort. So when we start using the comparable interface, if we really want to understand why the demonstration of this works, you need to know, first off, that both the classes of double and string actually implement the comparable interface. So if I actually look in the double wrapper class, not the primitive type, but the wrapper class, you will find that in there. If you were to check the full documentation of that class double, for example, you'll see the double implements the comparable interface, and so it has the compare to method. Moreover, for objects O1 and O2 of double, O1.compared to O2 is less than 0. Well, we know that O1 comes for O2. Means the same thing as saying O1.double value is less than O2.double value. All right, so if you were to try and convert those over into numeric types and then do an inequality, you, of course, would get the same thing. So the implementation of the comparable interface for the class double is just the ordinary less than relationship on the double values corresponding to those double objects. Similarly, if you check the full documentation for the class string, you'll see that string implements the comparable interface and so, of course, has the compare to method, which again we've seen when we looked at lexicographical versus alphabetical order. Moreover, the implementation of the compare to method for the class string is just the ordinary lexicographical relationship. So again, just what I talked about. Now, this programming example that we are looking at here is, of course, assuming a couple things. We have the standard library classes for double and string as the base type of those arrays. You can do the same thing with arrays whose base type is a class that you've defined. So if we had a class, let's say called my class, we could use it. So as long as that class would implement the comparable interface, including any of those standard semantics that we have discussed. Now, the program example, of course, that we have looked at here does point out one restriction on interfaces. They can only apply to classes. A primitive type cannot implement an interface. If you remember, when we looked at this, it was double with a capital D, not double with a lowercase d. So we could not sort an array with base type double using the sorted method for array of type comparable. Instead, we have to settle for sorting array with base type double. And even though this is not anything too big to worry about, because again, we can do automatic boxing and unboxing, this is a good example of using a wrapper class with its wrapper class quote-unquote personality, having it fulfill that purpose. And here we are looking at our generalized selection sort. You can see, of course, here we are using the comparable interface. It's right here in our sort right here. So we are using a comparable array, and that's how we are going to implement the interface. Notice we don't have to say implements or anything up here because, again, remember, this is part of the Java language, so we don't have to use a special addition here because it's part of java.lang. And down here, you'll again see that comparable array being used. And again, down here is being used as well because, remember, we are trying to replace anywhere it said double with comparable. And of course, you'll see comparable temp, comparable min. We have our compare to methods, which of course are doing the actual comparison. And that's really all you need to do is just change those out to make this generalized selection sort. In terms of actually implementing this, now of course we do have to use our wrapper classes here to go ahead and have this work properly. But again, one of the things you'll notice is when we actually get to calling that method, we just call it the same as we always do. So let's just give that a run. All right, so it says before sorting. All right, we have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Perfect. And after sorting, we're going 1, 2, 3, 4, 5, 6, 8, 9, 10. Excellent. And of course, that is, of course, just showing us with a double. What if I wanted to do a string? Well, here I have dog, cat, Cornish game hen. All right, looks pretty good. How about after sorting? Cat, Cornish game hen, dog. Excellent. And it's cool that we look at this because, again, remember, this is one big long string. So we can actually see that it's separating this as its own object here. So this is all one string. All right. And because what do we have? We have 3 variables in here. Now, if I go ahead and add in, let's say, one more. Just say a of 3. And let's have that equal. How about let's just make this a fish. Something simple. All right. And we're going to change this to 4 because now I'm using 4 of these in my sort. So I'm just going to go ahead and run this again. And you can see that it has updated that list now to include fish. Now, you can see a dog, cat, Cornish, game, hen, fish. Fish stayed at the end because that's the last item that was added. And then you can see here now it has kept it in its place because, again, it has sorted it from on lexicographic order. So we have, C, G, and then F. So again, a nice good demonstration of how we can use an interface to really kind of help us, for example, in this case, generalize our code. This is only one case example of using a double, but what if we were to use a different class type? We see double here now we can use a string type. What other ways could we think about? What other classes could we implement that could allow us to do something very similar beyond just the selection sort?